Hello everyone. Now today I am going to discuss SRTF scheduling algorithm, which is a SRTF preemptive version. Now in this question we have processes and their arrival time as well as their burst time are given. So just like all the previous problem, first we'll have to prepare a Gantt chart. Now this is preemptive version. What is preemptive? Preemption is basically when a process switches from running state to ready state or from waiting state to ready state. This is preemption. Before we have done SRTF non-preemptive version in which we cannot terminate a process in between, right? So here in SRTF preemptive version, first we'll have to prepare a Gantt chart, and for preparing Gantt chart we'll have to first check the smallest burst time. But before the smaller burst time, we'll check the arrival time also, because it is also given here. So which is having the smaller arrival time, process P0, right? At time 0, process P0 entered in the ready queue. So we'll prepare a Gantt chart. Now process P0 will enter in the running state because it has arrived at time 0. While solving preemptive version of any algorithm, you'll have to keep in mind that you'll have to execute process one by one. Like you'll execute one amount of time first, then you'll check the next arrival time of the next process, and then you'll compare the burst time and you'll execute that process which is having the smaller burst time. So here when we'll run process P0, first we'll execute it at only one amount of time, so it will become 4. Now at time 1, process P1 has also arrived in the ready queue, so it means that at this time we can execute both the processes P0 and P1. Now we are solving SRTF, so we'll compare the burst time. Like in SRTF non-preemptive version, we are also doing that. We are comparing the burst time. Similarly, we'll compare the burst time, and the process which is having the smaller burst time will get executed first. So 4 and 8, which is smaller? 4 for process P0, burst time is smaller. So again process P0 will get executed. Now again it will execute only for one time, and this will become 2. Now at time 2, we have all these 3 processes available. P0 can also enter, P1 can also enter, and P2 can also enter, because now P0 has finished its execution. If P0 will finish its execution at time 2, then P2 can also enter. Right, now we'll again compare the burst time 383, which is the smallest 3, but P0 and P2 both have the same burst time, right? So in this case, as I already told you in the previous video, when we'll have same burst time and in the SRTF, so we'll just check for the arrival time. Now arrival time 0 and 2, the process which is having the smaller arrival time will get executed first. So process P0 is having the smaller arrival time because it has arrived first. Now process P0 will get executed first before process P2. Now 3 is the smallest one, so no, there's no any other process which is having a smaller burst time than 3, so we'll execute this P0 completely. So 3 plus 2 is 5. Now P0 has finished its execution. It means all these processes P0, P1, P2 and P3 can enter in the running state, because at time 5 any of all the processes has arrived, and any of these processes can enter in the running state. Now again we are solving SRTF shortest job first, so we'll check for the burst time. So this is completed. Now 836, which is the smallest? 3, process P2. So process P2 will get executed, and 5 plus 3, because 3 is the smaller one, and if you can do perform one by one, there is no need, because this is the smallest one and there is no any other process which is having a smaller burst time than 3. Now after P2, 8 and 6, it has finished its execution. The remaining processes are P1 and P3, and which is having a smaller burst time, process P3. So process P3 will get executed. P3, and P3 is having 6, which is obviously smaller than 8, so it will execute completely 8 plus 6, which will equal to 14. Now at last the remaining process P1 will get executed, P1, and it is 8. So this is a Gantt chart for this problem. After preparing Gantt chart, we'll have to find out the finish time. So finish time for process P0 has completed its execution at time this time. So 5 is the finish time for process P0, and process P1 it is 22, and for process P2 it is 8, and for process P3 it is 40. After finish time, we'll calculate turnaround time, and turnaround time is the difference between your finish time and arrival time. Here it is also given. So 5 minus 0 is 5. 22 minus 1 is your 21. 8 minus 2 is your 6. And 14 minus 3 is your 11. After TAT, we'll calculate waiting time, which is TAT minus BT, 5 minus 5. Now 5 was the burst time for process P0, right? So 5 minus 5, 21 minus 8, just 13, 6 minus 3, 3, then 11 minus 6, which is 5. Now we'll calculate average turnaround time, which is the summation of all the turnaround time of each and every process upon total number of processes. 5 plus 21 plus 6 plus 11 upon 4, which is 43 upon 4, right? So this is the average turnaround time. Similarly, average waiting time, summation of all the waiting time upon total number of processes, which is 0 plus 13 plus 3 plus 5 upon 4, which is 21 upon 4, which is 5 point. So this is the solution for the given question. Thank you.